Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have x times square root of x minus square root of x is equals to 6, and we solve this problem for all the values of x. So if we focus on this square root term, we know about that the radicand which is lies inside the square root sign is always greater than 0, okay, because square root is always gives us the positive value. So this means that we just solve this problem for x greater than 0, or in other words, we solve this problem for all x belongs to R. It means that we solve this problem for real values of x only. This shows that in this problem our x should must be greater than 0, or in other words our x should must be positive. So according to these conditions we move forward to solve this problem. And here first you see that square root of x is lies on both of these two terms, so that we will be take here a is equals to square root of x. Sorry, this is square root of x. So when we put take a equals square root of x, and when we apply squaring on both of the sides, we will get here a square equals to x. So we substitute a square equals to x, and square root of x is equals to a to the given question statement, so that our given question statement is written as a square times of a minus a is equals to 6. So here we need more simplifications, and it will be written as in this form. This is a square times a becomes a cubed minus a is equals to, this is 6, and we break this 6 as in this form 8 minus 2. And now we find the prime factors of 8, and we know about that the prime factors of 8 are 2 cubed minus 2. And in the next step we move all the terms from right hand side to the left hand side, and we get a cubed minus a. This is 2 cubed becomes minus 2 cubed, this is minus 2 becomes plus 2, and this whole equation is equals to 0. And now here we make the pair of a cubed with minus 2 cubed, and from remaining two terms we will take common minus 1, and when we take common minus 1 we get the remaining values are a minus 2, and this whole equation is equals to 0. So here we use the nice cubic formula to solve this problem, and we know about that if we have x cubed minus y cubed equals to x minus y times of x square plus xy plus y square. According to this cubic formula, we expand the cubic term of the above equation as this is a minus 2 times of a square plus a times of 2 plus 2 square minus a minus 2 is equals to 0. So further in the next step we need more simplifications, and it will be written as we need to take common a minus 2 from here, and when we take common a minus 2 we get the remaining values are from here we get a square plus 2a plus this 2 square becomes 4, and when we take common this a minus 2 we get the remaining values are minus 1, and this whole equation is equals to 0. Further we need more simplifications, and it will becomes a minus 2 times of a square plus 2a plus 4 minus 1 becomes 3, and this whole equation equals to 0. And now in the next step we divide this equation into the two cases. The first case is we write a minus 2 equals to 0, and the second case is we write a square plus 2a plus 3 is equals to 0. In the start of the problem we just write that we solve this problem for only real values of x. So for this, first we check that is this quadratic equation has a real root or not by using the discriminant formula. So that's why we first write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 2, and c equals to 3. And we state the quadratic formula as we state the discriminant formula as delta equals to b square minus 4 times of ac. We substitute all the values of a, b, and c here. So the value of b is 2 becomes 2 square minus 4 times of a is 1 and c is 3. 2 square becomes 4 and 4 times 3 becomes 12, and 4 minus 12 becomes minus 8. So you see that our delta is equals to minus 8 and minus 8 is less than 0. This shows that our above quadratic equation has complex roots. So if this equation has complex roots, this means that this equation cannot gives us the real root, but we solve this problem for only real roots, so that we rejected this case. So if we rejected this case, this means that we proceed here this case only, and in this case we move minus 2 to the right hand side and we get a is equals to plus 2. So in the start of the problem, we will take here a is equals to square root of x. So we back substitute it here and it will become square root of a is equals to 2. And now for the values of x, we apply squaring on both of the sides and it will be written as in this form. This 2 and square root are gone and we get x is equals to 2 square becomes 4. So you see that in this case we get the value of x is equals to 4, and you clearly see here this is the real value of x. So now in the next step we need to verify that is this value of x be the solution or is this value of x be the extraneous root. So for verification of this we need to copy down given question statement. Here it is x times square root of x minus x is equals to 6. Here we substitute the above value of x and we check its behavior. So when we put x is equals to 4, it will becomes 4 times of square root of x minus square root of 4 equals to 6. We know about that square root of 4 becomes 2 minus 2 is equals to 6, and 4 times 2 becomes 8 minus 2 is equals to 6, and we get 6 is equals to 6. This shows that both of the sides are equal. It means that the value x is equals to 4 is satisfied our given question statement. And finally we have the solution set of this problem is x equals to 4. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.